Hi everyone, I hope you all are doing good. So, in my today's session, I'm going to cover the structural design pattern called bridge. Okay, so what is a bridge design pattern? Okay, the pattern is a design pattern used in software engineering that is meant to decouple an abstraction from its implementation so that the two can vary independently. Okay, introduced by the Gang of Four. Okay, the bridge uses encapsulation, aggregation, and can use inheritance to separate responsibilities into different classes. Okay, the bridge pattern is useful when both the class and what it does change often. Okay, so always remember in a bridge pattern, no guys. Okay, it is only used or useful when both the class, okay, here I would say class or noun basically. For example, if I take an example of message here, okay, my class is message and what it does, it sends message. Okay, okay, so that's what when the class and what it does means the verb here basically. Okay, whenever the noun and the verb keep on changing, in such cases you can use of bridge design pattern. Okay, so the class itself can be thought of as an abstraction and what the class can do as the implementation. The bridge pattern can also be thought of as two layers of abstraction, as I already said. Okay, the noun and the verb basically. Okay, what what is the thing, what is that object and what it does basically. Okay, so both these two things can be put into two separate layers of abstraction. Okay, so what problems can the bridge design pattern solve? As said, an abstraction and its implementation should be defined and extended independently from each other. Okay, a compile time binding between an abstraction and its implementation should be avoided so that an implementation can be selected at runtime. Okay, with the concept of inheritance or subclassing, okay, what happens, we can specify the binding at the compile time. Okay, they are bound together. Okay, the implementation is bound to its abstraction. Okay, the derived class is bound to its base class basically. Okay, that is at the compile time level, but we want at the runtime level. So this is the scenarios where the bridge design pattern should be used. When using subclassing, different subclasses implement an abstract class in different ways. Okay, but an implementation is bound to the abstraction at compile time itself and cannot be changed at runtime, which I already explained. What solution does the bridge design pattern brings to the table? Separate an abstraction, okay, from its implementation, that is the implementer, by putting them in separate class hierarchies. So in this example, for example, separate an abstraction, in my case message. Okay, I have a system which has the responsibility of sending messages, so message is my abstraction from its implementation or implementer basically. Implementer is who sends the message basically, the message sender. Okay, so message and message sender, basically I'm going to separate them by putting them into separate class hierarchies. Okay, now implement the abstraction in terms of or by delegating to an implementer object. Okay, so this enables to configure an abstraction with an implementer object at the runtime. I'm going to show you with an example soon. Okay, don't worry about it. Now let's have a look at the UML diagram. Okay, abstraction, so take an example of a message here, message sending system. So abstraction is a message basically. What kind of message? It can be text message, email message, push notification, whatever. Okay, so this is the abstraction and it should contain the implementer. Okay, so who is the implementer? The implementer is the one who implements the abstraction. So in my case, my message is the abstraction and who is implementer? Okay, implementer is message sender who sends my message. So what I will do, in my abstraction I keep a reference variable or keep a reference or a pointer to my implementer. Okay, and then the function, and what this function do, it simply calls your implementer's implementation. That's it. Okay, so if I take example of my message sender, so my message sender is implementation. So what this function does, this function simply invokes this dot message sender dot send. That's it, so it will send the message. So that is the crux of this particular bridge design pattern. Okay, so again, for the abstraction, you have a refined abstraction or you can call a concrete abstraction, which provide the refined method. So if I have a message as my abstraction, so I can have a text message, I can have an email message, so I can inherit and create concrete classes over here. Same way for the implementer also. So implementer is basically a interface here, whereas abstraction is a abstract based class. So for this implementer interface, for this contract, I have an implementation that is send a message. In my case, it is message I message sender, and it contains only one method, that is send a message. So the concrete implementer will provide the concrete implementer for sending a SMS message, that is a text message, and for sending the email message. Okay, so that's all about the class diagram, very simple. Okay, so I have already explained this, what is abstraction, refined abstraction, implementer, and concrete implementer. Now, what are the advantages of bridge design pattern? Bridge pattern decouple an abstraction from its implementation so that both can vary independently. Okay, so if you take an example over here, today I have only two types of messages, like SMS message and email message. Okay, and I have a SMS sender and email sender. Tomorrow there will be one more kind of message. Okay, tomorrow I want my system to implement one more kind of message. Okay, like a multimedia message, MMS message. Okay, in that case, what I will do, I will simply inherit from my abstraction message. I will create a new message type called MMS message, and also I provide a implementer, that is the message sender, I message sender. So the way how I have SMS message sender and email message sender, I will create one more class called MMS message sender. See the beauty of this design pattern. You are nowhere disturbing your client. Your client will always deal with the abstractions or the abstract base class, and the interfaces, basically the implementer interfaces. Okay, so that's the beauty of this pattern. It is used mainly for implementing platform independent features. Yes. Okay, so sending messages is basically a platform independent feature. It should not depend on your Windows or Linux operating system. Okay, so on any platform you should be able to send any kind of messages. Okay, it adds one more method level redirection to achieve the objective. Yes, it they basically, whenever I want to send a message, right, first what I will do, I will call my implementer dot implementation, and implementation will make the actual functionality or implement the functionality. Okay, so that's what all about the bridge pattern. So as you can see, abstraction, it contains a function, again redefined refined abstraction, which contains the refined function, which is nothing but overriding this function itself. So whenever you call this method, right, okay, this refined function, it basically redirects this call, okay, to your implementer's function. So that's what they are speaking about in this point. Okay, it adds one more method level redirection to achieve the object. Publish abstraction interface in a separate inheritance hierarchy and put the implementation in its own inheritance hierarchy. Okay, so this is a separate hierarchy. So today I have a SMS message, I have an email message. Tomorrow if I want a MMS message, so it will be added to MMS message, which is inheriting from this abstraction. This is a separate category, and implementer, which basically sends all these kind of messages. So tomorrow if I introduce the MMS message sender, then it will come into this particular category of inheritance. Okay, that's what the this point speaks all about. Use bridge pattern to runtime binding of the implementation. Yes, we achieve runtime binding with this pattern. Use bridge pattern to map orthogonal class hierarchies, which I already explained. The message and the message senders, basically. Okay. Bridge is designed upfront to let the abstraction and implementation vary independently. Yes. The same point, I think I copy pasted twice. Okay. So let's go with the demo now. So a very trivial example, I have used the message sending system to demonstrate this. So I will just explain this particular example by referring to my UML class diagram. Okay, so very simple. If I go to my class diagram, my abstraction, my noun in my system is basically message now. Okay, message is my noun here. Okay, or the core functionality which I want to perform, it's called messaging. So message is my abstraction and implementer. Who implements this functionality? Okay, message sender. Okay, so I will I will go through all the classes which I have created. So public abstract class message. Okay, this is my core abstraction of message. Now, can you see this is the abstract base class and it has a reference to my message sender, the implementer. See the composition of implementer abstraction or a reference to implementer. You can see here the implementer. Okay, I have a reference to my implementer, which is a composition basically. You can see this symbol, the diamond symbol. Okay, then I have a abstract method send. Okay, which will do the operation of sending this message or my message basically. Okay, now we will go to the concrete implementation. So I want my system to support text message, which basically inherits from message abstract base class over here. Okay, and what I'm doing, I'm basically sending a message sender to my text message constructor, and I'm calling the base class constructor to set the implementer or the message sender, which happens over here. Look at the reference variables. Everything is being achieved using the interface reference variables and abstract class reference variables. Okay, nowhere I'm specifically mentioning any concrete classes. Well and good. Same for the email message. Okay, same setup. Constructor will receive the message sender and we will forward that call to the base class constructor and it will set the message sender. And I have overridden the send method in order to send the message. Okay, message sender dot send message. So can you see this method over here? Okay, the function, this function or this refined function is basically redirecting the call to the implementer. It's not doing anything. Simply it will call the implementer's implementation function. So if you see over here, my iMessage sender is the implementer and I on this message sender, I am simply calling send a message when I call this send method. Okay. So go ahead. My contract for the implementer, which is iMessage sender, very simple interface, public interface iMessage sender, which has only one method, send message. Okay. Now I will provide a concrete implementation to my message sender. So in order to send a text message, I have a text message sender. Okay, and the logic related to sending text messaging, right? Setting up a SMTP, sorry, setting up a SMS server, making a connection, sending a text message, all those things will take place in this class. Okay, so for a demonstration purpose, I'm just saying send text message. That's it. Again, for the email message sender, what I will do in my send message, I will implement the send message method from my contract and I will basically perform the various operations required to set up a connection with the SMTP client. Okay, and then construct the SMTP client, establish the connection, create the message body. Okay, set the to address, from address, and all those operations will take place and I will send the email message. Okay, so if you come to the main method now, very simple. I message sender, text message sender equal to new text message sender. Okay. When I create a message, see the references I'm making use of. I'm using all the abstract base class and interface reference variables. So message text message equal to new text message, pass the sender so that the sender will be set into my uh, concrete implementation of text message. Okay, and by forwarding the call further to my abstract base class. Okay, when I do text message dot send, okay, this basically sends a text message. Again, for a email message sender, I will create a email message sender. Okay, I will construct a message, email message equal to new, oh sorry, it should be email message, let me correct it, email message, and yes, I will pass the image message sender. Okay, and when I call image message dot send, the send will internally call the image message sender, so send a message method, and it will send an email message. Okay, if I run this, control F5, so you can very easily see the text message sender sent the text message, email message sender sent the email message. Okay, so that is all about this bridge design pattern. Okay, and you can see there are two category of classes. Okay, uh, one is your message. Basically, this is one category related to message. This is the abstract base class message and its hierarchy: text message, email message. Again, there is one more category, okay, which is called iMessage sender and its respective inheritance hierarchy, that is text message sender, email message sender. So basically you can see a orthogonal the orthogonal set of classes which are heading in two different directions. Okay, one for message, one for message sender. Okay, so this is how the bridge pattern works, guys. Okay, very simple, and this pattern is very useful. I have already explained what all scenarios you should make use of this. Okay, thank you for listening and have a nice day.